good day. In algebra, we'll be covering our first objective of the year, CO1, classifying a number as rational or irrational. So like we talked about, these binary symbols here of this wise old owl represent a term, a word that we're going to define. And these can go on a help sheet. So it might behoove you to start making your help sheet as we go through the unit rather than waiting to the very end and thinking back. What did he say was important again? What should I write down? You might want to start building it kind of as we go along. But anyway, what is a rational number? Does anybody know? Yes?
A number that has a defined end.
A number with a defined end. I like that. Say a little more. What does defined end mean?
Like 25 or like 25.12.
Yeah, good. So a rational number is a value with a decimal that ends, that's that defined end piece, or repeats. A value with a decimal that ends or repeats. So an example of a rational number might be 8. Now, is 8 a decimal? Not really, but can we write it as 1? How? What would it be? 8.0, which is a decimal that ends, so therefore it is considered rational. Okay. Something like negative 6.125 would be rational because the decimal ends. Okay. How about fractions? Are fractions rational? Like if I had the fraction 3/4, would that be a rational number?
It's rational, like if it divides like equally or good or evenly.
Actually, any fraction, as long as it doesn't contain a non-perfect square, we'll talk about that in just a little bit, but any fraction can be written as a decimal that either ends or repeats. In this case, it's 0.75. Okay, so that would be rational also. That would be rational also. So those are examples of values with an ending decimal. What about a repeating decimal? What's the math notation for repeating? Exactly. So if we had something like 7.25 with a line over the 25, that decimal is actually 7.25252525252525. But mathematicians being inherently lazy, we always want to make things as efficient and short and quickly done as possible. So rather than write out that whole long thing, we have that line over the 25 to show it repeats. That would be a rational number as well. Okay? Question so far? Good. So if a rational number is a value with a decimal that ends or repeats, irrational kind of sounds like the opposite of rational. What would that be? What would an irrational number be? Bridget? Well, sorry? Never ends or never repeats. So an irrational number is a value with a decimal that does not end or repeat. The decimal goes on forever. What's the most famous irrational number that kind of always comes to mind as an example? Pi. Yeah. It's so important we have its own symbol, right? It's used significantly with circles and such, but it is an irrational number. Computers have calculated that decimal out to 2 billion places, and it still hasn't ended, and there's no sign of it repeating. So, of any repetition anywhere. So it's a pretty amazing number. Other types of irrational numbers that you will see are the roots of non-perfect squares, such as the root of 20. Okay? 20 is a non-perfect square because if I gave you 20 dots, you could not form a square. You could make a 2 by 10 rectangle. You can make a 4 by 5 rectangle. You can make a 1 by 20 rectangle, but you can't make a square. There's no number that when you multiply it times itself equals 20. And so if you were to type root of 20 in your calculator, your decimal would go on forever without ending and without repeating. Okay? Give me an example of another non-perfect square. Root of 15 would be an irrational number. Give me an example of a perfect square, one that when you take the root of it would actually be a rational number. Brent? 36. Good. We'll put that up top here. The root of 36 is actually rational because the value of the root of 36 is 6. 6 times 6. What's your experience with roots? Have you worked with them pretty extensively? Do you know what they are? Okay. All right. Well, there's some review that we'll need to do perhaps, but at least you have the general idea. The other mathematical notation to represent an irrational number, anybody know? Yes?
Isn't it like dot?
It's dot, dot, dot. So if we had something like 1.9248 dot, 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 that dot, dot, dot means it continues on. It's kind of like when your parents send you a text message. How was school today? And you respond, fine, dot, 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 right? There's more there, okay? You just didn't write it, all right? Kind of the same thing here. That means that it continues on. The decimal does not end, does not repeat. So that would be an irrational number as well. Okay? Good? All right. Did I hear a nope? No, I didn't hear a nope? Okay. All right. So down to some I got to put the pen down. I keep forgetting that. Whenever I got to, then there we go. And then we're just going to, geez. Live teaching. There you go. Remember, the root of any non-perfect square will always be an irrational number. We kind of talked about that. It is a key point, so I can go on a help sheet. How you can check your answer, and I'm going to require this when you do your homework. If all you write is rational or irrational, I'm not going to give you credit for it. I would like you to defend the reason why. Why is negative 12.7 rational? And if you just want to put an R there, that's fine. Okay, but why is negative 12.7 rational? What about that value makes it rational? Yeah. Okay, so the decimal ends. That's all you need to put there. The root of 36, we already defined that as being rational. Why is it rational? Yeah. Right, its value equals 6, right? And the decimal ends. So just something there that tells me that you thought about it, you have a reasoning behind it. It wasn't 2 minutes before class started, so you just wrote letters down, right? Something there. Pi, we talked about that as irrational. Don't just write I for that, because I in math has a couple other meanings also. Put IR. I know it's a little bit extra work, but you can handle it. Okay? And the reason why is that the decimal goes on forever. Okay? Yeah?
On the help sheets, do we just do like a loose leaf or is there...
Loose leaf, no card, whatever you want to do. Notebook paper, yeah. Okay. Any of the other 8 that you want to talk about? Yeah. No, not all of them. Pick one. Is there one that looks particularly? Yes.
3.12121211.
Okay. 3.1211121112 dot, dot, dot. So we see the dot, 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 right, which kind of clues us in that it's an irrational number. But then we also see something going on here, right? Those don't seem to be just simply random values. 1, 2, 1, 1, 2, 1, 1, 1, 2. Does that mean that this decimal repeats itself?
No.
No, it does not. There's definitely a pattern here, but a pattern does not mean repetition. Okay? There is a pattern, but it's not repetition. That dot, dot, dot does classify that's irrational because of the dot, dot, dot. Goes on forever. Question? No, I think I'll let you do the rest of them for homework. Give you something to do. I mean, we do have 20 minutes left yet. So, Elise.
What would you write for a fraction?
For fraction, you could either write its decimal value if it works out evenly, okay? Or if it wouldn't, then you could just say fraction. Either one. Now, the exception to that, of course, is if you had something like, 2 over the root of 10, okay? That would be irrational because that non-perfect square is a part of it, but that's not going to happen too often. Yes? Okay, so do you know how to put a square root in your calculator? Do we need to cover that? Okay, so for square roots, either it'll end up being a whole number answer, like 3 or 10 or 8. If there's any decimal behind it, okay, that reaches the end of your calculator display, it's going to be an irrational number. Okay. Yes?
For our calculators, they round up.
Yeah.
So for
At the end of it?
yeah, so instead of repeating, it would be the next number.
I'm glad you said that. Every year I come across this. So if you were to take 2/3 and get the decimal value in your calculator, what's the decimal value of 2/3? 0.6 repeating, right? But your calculator has all those sixes, and then whenever you run out of space, it throws a 7 there, and because it rounds up. And so folks come in and say, well, no, it doesn't repeat because there's a 7. Whew. That's where you have to remember you're dealing with a machine, right, that has its quirks. And this is one of the quirks, that it does round up here. So is there a question that you're asking specifically about that? Or?
Oh, yeah, for the third one, it just rounded up. It doesn't say
Oh, it takes 0.5 and rounds up to 1. So that's a that you've selected on your calculator to tell it to do that. I can fix it for you. Yeah. Let me, can I borrow your calculator quick? So if you go to the, I used to know where it was. That's not it. That's not it. That's not it. The other thing that you'll find out is I don't know how to edit these videos. And so whatever, this is just going to be a part of it. Is there a, nope. I might have to come back and take a look at it and play around with it a little more. Yeah, I can't remember where it is. Oh, never mind. So down at the decimal point, above that on the calculator, it says FIX, fix. So to get that fix, you want to press the second function first, way up in the top left, and then press your decimal point, and you should get F, and then the numbers 0 through 9. What's it selected at now? It is? It should be. Yeah, so move it to F and select F, and that means float, and then it should not round up anymore. Did it work? All right, I'll come back later. Okay. So that's the top part of your homework. The second part, I've got a few questions for you to do. The directions are answer each question. The first one says, write the value of 7 3 ways as an integer, as a fraction not in simplest form, and using a square root. Okay. Now the key here is you're writing the value of 7. Your fraction in simplest form might not have a 7 in it anywhere, but still has a value of 7. Okay? Same thing with the root. So think about that. Different ways to write various values. In our number system, are there more rational numbers or more irrational numbers? So think of the definition of each of those things. Which is there more of? Don't just give me an answer here. Explain why, right? Defend it. Defend it. And then finally, the last one for review, describe whole numbers and integers. If you talked about this last year, perhaps you have your notes or you remember. If you did not, then the Google will help you define them. So define whole numbers and integers. Question? Yes?
What's an integer again?
Or you can ask me. Anyone know what an integer is? Yeah, Elise.
It's negative or positive, but it doesn't have any decimals.
Right. It's a negative or positive non-decimal non-fraction. So like 4.5 would not be an integer. Negative 5 would be. Okay, those positive or negative non-decimals, non-fractions. So it'd be.
So you want us to write the number 7 as a fraction?
I want to write the value of 7 as a fraction. Okay, it's not going to be the number 7, but the value. So what is a fraction that if you were to simplify it would have a value of 7? That's what I'm looking for. Is there a question?
I was just gonna ask to simplify. I was just gonna ask the same question. He was like, fraction, does it have to simplify to 7?
Right, right. So it has the same value of 7. Yes. Yes. Spoiler alert. Yeah. For the integer of 7 would be just 7. Okay. I think that wraps it up. Any other questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Yes. The homework is to finish the page. Okay. Yeah. Any Mr. Happy Pencil section that we come across, that is your homework. Usually, unless I otherwise say it, the homework is going to be to finish the page. It is due the next day that we've got class, which would be tomorrow. So come with this done for tomorrow. Yes. It's the 3 questions at the bottom and the 8 or so that we didn't do up in the middle section there. Okay, so you're classifying as rational or irrational, and then answering these questions here. Yes.
How do you type 4.12 repeating in your calculator?
Depending on your calculator model, I think you're just doing 4.12121212. Why would you be typing it in there? So I don't think you would need a calculator for that necessarily, because if you know that it repeats, right, 4.12121212, that is the definition of a rational number. So that one you wouldn't need a calculator for, I wouldn't think. Bridget.
So all the fractions, are they going to be all rational?
Yeah, unless they contain that root of a non-perfect square, which none of them on that page do. So fractions are going to be rational. So Ib.
How will we check our homework?
Tomorrow you'll come in, you'll have your binder open to this page. I will come around with my fancy clipboard here, and I'll mark down whether it is done or not, and then we'll move on after correcting and taking questions and things like that. So remember, I don't grade homework on right and wrong, just that you give it your best shot and complete it. So if you have a question on something, don't write a big question mark or IDK, give it a try and then bring it for questions. If you want to send me an email with questions tonight because you're just stuck, all I'm going to be doing is watching football probably, so got nothing better to do but answer your email. So send them my way and I can help there too. Okay? All right, folks, let's not forget this. That is how you math.
Don't forget to like and subscribe.
I think we can do better. That, folks, is how you math.
Don't forget to like and subscribe.
Progress made.